In this next set, I'm going to do all the odd problems that have to do with solving the equations that have logs in them. So let's look at number 27. That one is sort of a simple log expression or log equation. And one way that we can solve it is to change this to exponential form. So I see that our base is 4, so that's going to mean my base on the exponential equation is 4. And over here we have 0, that's going to be my exponent because doing the log gives me the exponent. And then that's going to be equal to whatever the argument of the log was, so 2n. Now at that point we need some properties of exponents. Anything to the 0 power is 1. So I have 1 equals 2n. And then we have to look at what's happening to the n. Well, it's being multiplied by 2, so the opposite is divide by 2. And that means we get n equals 1/2. Now, of course, we want to check our answer. So go ahead and plug that back in. So log base 4 on 2 times 1/2. Find out what that's equal to. So 2 times 1/2 is 1. And what exponent do we need to raise 4 to in order to get 1 so that we can evaluate that log? Well, it's just 0, so that does check out. Looking at some a little bit harder log equations to solve, we need to isolate the log before we can change forms over. So before I switch to exponential form, I need to isolate that log. So I'm going to add 1 to both sides. That minus 1 is not included in the log, or else there would be parentheses around it. So rewriting, I get log base 6 on negative 9x minus 2 equals 0. And then I can change to exponent form. So the base of my exponent is 6, and 0 is my exponent. So I get 6 to the 0 equals the argument, so negative 9x minus 2. 6 to the 0 is actually just 1, so I get negative 9x minus 2 is equal to 1. And now I'm just getting x alone, so add 2 to both sides. I get 3 equals negative 9x, and then we want to divide by negative 9. And what that's going to give me is x equals negative 1/3. And then I just want to check it real quick just to make sure that it does work. So I get log base 6, negative 9 times negative 1/3 minus 2 minus 1. Okay, and then trying to evaluate here. We get negative 9 times 1/3, so that'd be positive 3 minus 2. And 3 minus 2 is 1. And log base 6 on 1 is going to give us the exponent we need to raise 6 to in order to get 1 at 0. And that would be negative 1. So it does check out, so I can be confident in my answer. And number 31, that is going to require use of our properties of logs. And what that says is if I have two logs that are added to each other, then what I can do is condense them into multiplication. So using that property, I can condense these logs. And notice I don't have a base on that log. That means that the base is going to be 10. So I can rewrite this as 7 times 2x. And that's going to be equal to 2. Then I'm going to simplify. 7 times 2 is 14 equals 2. Now I'm going to switch to exponent form. Remember we have the invisible base 10. So my base is 10. What's on the other side of the equal sign is my exponent, and that's equal to 14x. 10 squared is 100. That's equal to 14x, and then we're going to divide by 14 in order to get x alone. So that's going to give me x equals, and those are both even numbers, so that's 50 over 7. Then I want to plug it in just to make sure everything is okay. So we have this. Alright, and then we're going to simplify it, so I'm going to do that multiplication here. So log base of 100 divided by 7. And then I'm going to, because these aren't numbers to figure out exponents, I'm going to use that property of multiplication again. So 7 times 100 over 7 is 100. Okay, log base 10 on 100 is 2. So that does check. And our last one is a little bit more complicated. We're going to need to use the properties of logs again. Notice I have log in 3 spots, so what I'm going to do is condense them all into one place. So I'm going to minus log base 2 on 62. Then I get log base 2 on x plus 29 plus log base 2 on x minus log base 2 on 62 equals 0. Okay, so now I'm just going to use my properties of exponents. So let's condense these. They're all log base 2. I'm going to have x plus 29 times x, and that's all going to be divided by 62, and it's equal to 0. Now we could go ahead and do the distributing before we move on to turning it into exponential form, but because this is so complicated, I'm just going to put it in exponential form first. So I have 2 to the 0 equals x plus 29 times x all over 62. And 2 to the 0 is 1, so I know I can simplify that. And I'm going to go ahead and distribute that x there. So I've got x squared plus 29x all divided by 62. I don't really want to get rid of that divide by 62, so I'm going to go ahead and multiply both sides of the equation by 62, and then we'll kind of address some more things from there. So I get 62 equals x squared plus 29x. Okay, that looks a little bit nicer. Now the thing is that I realize I have a quadratic equation, which means I need to use some methods for solving quadratics. So those would be like using the quadratic formula or factoring. Before I do those, though, what I'm going to have to do is put this into standard form, which it is not in standard form right now. So I'm going to come up over here, and I'm actually going to subtract 62 from both sides, because standard form means I have 0 on one side and all my stuff is on the other side. So I get 0 equals x squared plus 29x minus 62. I don't really like the quadratic formula, so I prefer to factor whenever I can. So I'm going to take a second and try to think of numbers that multiply to negative 62 but are going to add to 29. So my two numbers that are going to work are going to be 31 and 2. And 31 is going to need to be positive because I want to add to that middle number, and that number is positive. So rewriting this in factored form, I'm going to have x 31, x 2. 31's got to be positive, and 2 has to be the negative 1. Then setting each factor equal to 0. So for that first one, I've got x plus 31 equals 0. So when I subtract 31 from both sides, I'm going to get x equals negative 31 for one of my answers. And then my other answer, when I set that equal to 0 and I add 2 to both sides, I'm going to get x equals 2. And then I want to go ahead and check these answers also just to make sure that they do actually work. So checking negative 31 first, I have log base 2 on negative 31 plus 29. And actually, I'm going to kind of stop there because I already see a problem of what that's going to equal. Because this argument's going to be negative 2, and this argument's negative 31, and these are supposed to be greater than 0, so that's going to be an issue. And what that means is x equals negative 31 is an extraneous solution, so that's not a real solution for us. And then I'm going to check on x equals 2 and see if that's okay. So log base 2 on 2 plus 29 plus log base 2 on 2. So that gives me log base 2 on 31 plus log base 2 on 2. I'm going to use that multiplication property that says when I have two logs that are added together, I can just multiply them. So that's going to give me log base 2 on 62, which is what's on the other side of the equal sign. So that does make the equation true.